Hello, my name is Alex Baxter, and I'm going to be talking to you about the Luray Caverns in Shenandoah Valley, Virginia, USA. I visited the Luray Caverns in 2010 and became deeply inspired by its beautiful scenery and geology. The Luray Caverns are a network of eroded limestone and coarse-grained crystalline dolomite. Through the action of mildly acidic water, the caverns were carved out over the course of millions of years and eventually formed many small and large beautiful structures composed of calcite. These calcite structures are known as stalagmites and stalactites. The entire network of caverns is only about 100 feet thick and is completely dominated by the existence of millions of these stalactites and stalagmites. The formation of the Luray Caverns began when limestone from Shenandoah Valley began to dissolve and dilute carbonic acid in water. Carbon dioxide from the atmosphere and surrounding vegetation had dissolved in the water and formed this dilute carbonic acid. Encased in a sheath of coarse-grained crystalline dolomite, the caverns began to hollow out over the course of millions of years through the action of the dilute carbonic acid in water. Once the major bodies of water had emptied from the cavern, only minute amounts of water traversed and entered the cave by seeping through small pores in the surrounding rocks and soil. Carbon dioxide gas began to boil out of the water and fused with the dissolved calcium carbonate from limestone due to the characteristic atmosphere of the caverns. This caused the calcium carbonate to precipitate out of solution and form crystalline calcite deposits on the ceiling and cavern walls. As the water slowly dripped down from the ceiling of these caves, calcium carbonate started accumulating on these calcite deposits and began forming pointed rock-like structures called stalactites. When the water droplets hit the cavern floor, they begin forming another structure known as a stalagmite. Stalagmites are formed by the same process as stalactites, but point towards the cavern ceiling. When a stalactite and stalagmite unite, they form what is known as a column. These three mineral structures, stalactites, stalagmites, and columns, are collectively known as dripstone due to the nature in which they are formed. In other cases in the Luray Caverns, calcium carbonate dissolved in water flows over a ledge or on top of existing rock and forms what is known as flowstone. These deposits are usually more massive and create large draperies that look like frozen waterfalls. The stalactite and stalagmite structures in the caverns are believed to have begun forming around 200 million years ago after part of the Americas collided with Africa due to tectonic plate activity. The formation of these calcite structures is still an ongoing process where new deposits are formed at a rate of 1 cubic inch every 120 years. The main rocks present in the Luray Caverns are coarse-grained crystalline dolomite and limestone. The limestone is composed of the minerals calcite and aragonite, which are the predominant minerals that dissolve in the water and are deposited on the cavern walls and ceiling. Calcite from the Luray Caverns is not actively extracted or harvested for anything, but instead serves an aesthetic purpose. Calcite in general, however, is extracted from many other sources in the form of limestone, and is a common building material for buildings and decorative pieces. Limestone is a relatively soft rock and is thus easily shaped and is easy to work with when creating or building structures. There are many other cave structures similar to the Luray Caverns all over the world. The Jeta Grotto, located in Jeta, Lebanon, is a very similar limestone cavern filled with magnificent calcite stalactites and stalagmites. The Jeta Grotto currently holds the largest stalactite in the world. The Luray Caverns is overwhelmingly filled with beautiful scenery and structures. Mirror Lake, a truly awe-inspiring scene, is a magnificent array of stalactites hovering over a veil of perfectly still water. The lighting in the cave gives the illusion that the lake is actually an array of stalagmites arranged symmetrically but opposite to the ceiling. It is, however, just a reflection of the ceiling on the surface of the water. Perhaps the most bizarre fact is the existence of the stalacpipe organ, the world's largest natural musical instrument. When its keys are pressed, an electrical signal causes a mallet to tap on a distant stalactite to create an organ-like tone. It took 36 years to design and implement this instrument. Thank you for taking the time to watch this video presentation. I hope you enjoyed it and learned something.